Here are two problems for you to solve. In this example, we were using intercepts alpha 1 and alpha 2. Alpha 1 was specific to lab 1 and alpha 2 was specific for lab 2. Now suppose I tell you what alpha 1 and alpha 2 are. They are known, which is very natural because I am sure that you have noticed that alpha i's are nothing but the initial unstretched length of the two springs. So you might just directly measure them. So it's quite possible that you have already measured them, so you know alpha 1 and alpha 2 for sure. If that is the case, then you have only one parameter beta. Now can you express that as a linear model? Suppose I tell you that alpha 1 is 5 and alpha 2 is 10 or just whatever. So can you write that as a linear model and then solve it? The second problem is similar but slightly more difficult. We have already seen that alpha 1 is the initial unstretched length of the spring used in lab 1 and alpha 2 is the initial length of the spring in lab 2. Now suppose these two labs are situated far apart and the main investigator sits in lab 1 and a subordinate investigator was sent to lab 2. The instruction was that you should first measure the initial length before anything starts so that you know exactly alpha 1 and alpha 2. Maybe alpha 1 and alpha 2 are actually part of the specification of the springs themselves, so it is not measured, they are known exactly. But unfortunately, the subordinate investigator who was sent to lab 2 ignored that duty, forgot to write down the initial length of that spring. But in lab 1, the principal investigator has quite correctly measured that length. So you know the exact value of alpha 1, but you do not know the value of alpha 2. This is a very common situation where you have to carry out the experiment spread out over multiple labs, and in some of the labs some of the measurements are not available. In that case, how will you cast this as a linear model and how do you solve it using R? So that is the second problem.